Okay, so today we're going to be looking at practicing reference angles and finding the basic trig functions for them. So definition of reference angle is the angle made with the terminal side and the x-axis. So as I look at my angle over here, I want to figure out what measure is it making with the x-axis. So my angle started here initially and it went clockwise, which is why it's negative, and it ended over here. So this is my terminal side. My initial side is always 0 degrees, the x-axis. And so the angle my terminal side makes with the x-axis is this wedge here. Okay, so notice it's not the actual, it's not all of this spiral. It's that pink portion there, that wedge it makes. And so to figure out its angle of reference, we have to figure out a couple things. We have to figure out what's its coterminal value between 0 and 2 pi. And then what does that coterminal angle make with the x-axis? So we're going to start by finding its coterminal value. You have to find a coterminal value anytime it doesn't fall in a single circle. A single circle is 0 to 2 pi or 0 to 360. So to find coterminal angles in radians, I'm going to add multiples of 2 pi. I can add 2 pi at a time, or I could do multiples of it. So instead of 2 pi, I could add 4 pi, or I could add 6 pi. Okay, so you can do it either way. I am adding because it is a negative angle. If my angle was too big, if my angle was more than 2 pi, then I would subtract values of 2 pi to make it smaller. So I'm going to be adding on 2 pi. And so let's get 2 pi to have a common denominator. So my radian is over 6, so I'm going to multiply 2 pi by 6 over 6. And so I'm going to get negative 23 pi over 6 plus 12 pi over 6. Well, if I add this, I'm still going to end up with a negative angle. That's only getting rid of one loop of my circle. That's basically bringing me back to right here on my loop. So I still have this extra loop going on. So I'm still going to be negative. So this is negative 11 pi over 6. So I'm closer, but I'm not there yet. So I'm going to add another multiple of 2 pi. Now, since we've already found that 2 pi is the same as 12 pi over 6, let's just go ahead and write it as plus 12 pi over 6 from now on. So I'm going to add 12 pi over 6. So negative 11 pi over 6 plus 12 pi over 6 is just pi over 6. Now, in this case, my coterminal angle happens to actually be the reference angle as well, because pi over 6 is acute. Okay, so 90 degrees is the same as pi over 2. And so any radian less than pi over 2 is an acute angle. And so 1/6 is less than 1/2. So this is acute. So my reference angle is pi over 6. Your coterminal angle and your reference angle will not always be the same thing. All right, let's look at another one. All right, negative 420 degrees. Now we're in degrees, so we're going to be looking between 0 and 360. I need to figure out my reference angle, which is going to be this wedge here between the terminal side and the x-axis. But first, I need to figure out its coterminal angle. Where is this that it would land on the unit circle? So since it's negative, I'm going to add to it. And since it's in degrees, one full loop of a circle gets me back to the same spot. So that's why it'd be coterminal. So I'm going to add one full loop of a circle. I'm going to add 360 degrees. So if I add 360 degrees, I am left with negative 60 degrees. Well, I'm still not to a positive angle between 0 and 360. So I need to add another multiple of 360. So really, if I had just added 720 to begin with, which is 2 times 360, I would have gotten straight to my answer. But it is okay to just do individual additions of the circle. So negative 60 plus 360 is 300 degrees. So my coterminal angle, where this would be on the unit circle, is 300 degrees. But 300 degrees is not an acute angle with the x-axis. So this is not my reference angle. My reference angle is the angle this makes with the x-axis. So my reference angle, we're going to actually have to figure out it's how many degrees away from the x-axis is it. And so your x-axis has 3 different measures. You start at 0 degrees. When you get halfway over to this end, you're at 180 degrees. And then when you've looped to a full circle, you're at 360 degrees. So which of these 3 values is 300 closest to? Well, it's closest to 300. Sorry, it's closest to 360. So I'm going to do 360 minus 300. And 360 minus 300 is 60 degrees. So my reference angle is 60 degrees. Let's look at it when it doesn't have a picture for us. You have a couple things you can do as a picture when there's no picture is one, you could draw it. Okay, and it could be beneficial to draw it. Or you just got to get really familiar between what's between 0 and 2 pi. Since this is over 6, 0 to 2 pi would still be 0, but 2 pi would be 12 pi over 6, because 12 over 6 is 2. So we want a value between 0 and 12 pi over 6. So I'm going to start by finding my coterminal. My coterminal is my positive value in the first loop of the circle. So since it's negative, I'm going to add 2 pi to it. But again, to add, we need that common denominator. So we need to multiply by 6 over 6. So I get negative 17 pi over 6 plus 12 pi over 6. And that's negative 5 pi over 6. So I'm definitely not between 0 and 12 pi over 6 yet. So I add another multiple to it. And negative 5 pi over 6 plus 12 pi over 6 is 7 pi over 6. Okay, so 7 pi over 6, that is between 0 and 12 pi over 6. So it is between 0 and 2 pi. So this is now my coterminal angle. And so on my unit circle, this is 0 radians, this is pi radians, and a full loop is 2 pi. But if we want to think of their comparison to over 6, that's 0, that's 6 pi over 6, and that's 12 pi over 6. So is 7 closer to being 0, 6, or 12? Well, it's closest to being 6, so it's closest to pi. Which if you drew 7 pi over 6, it's over here. So visually you could see that it's closest to the pi value. So to find my reference angle, we're going to subtract pi from it. We're going to subtract pi from it because it's bigger than pi. So I'm going to do 7 pi over 6 minus pi. But what was pi? Pi was 6 pi over 6. So 7 pi over 6 minus 6 pi over 6 is 1 pi over 6. And so there's my reference angle. Now, finding the exact value of a trig function. If I'm looking, I have 2 ways to do it. I can either look at my special right triangles or I can look at my unit circle values. Now, your 2 special right triangles were 45, 45, 90 or 30, 60, 90. Well, 45 is the same as pi over 4. 30 is the same as pi over 6. So 45 degrees is pi over 4. 30 degrees is pi over 6. And 60 is pi over 3. So if you did the conversions, that's how they relate. So if I see sine of pi over 4, that relates to my 45, 45, 90 triangle. So I could look at the unit circle, or I could look at my special right triangle. And my special right triangle, since we're talking about the unit, has a hypotenuse of 1 and side lengths of root 2 over 2. So sine of 45 would be the opposite over the hypotenuse. Well, root 2 over 2 over 1 is just square root of 2 over 2. Now again, I told you could have used the unit circle. So let's take a look at a unit circle. Here's a unit circle. If I look at this unit circle, over here I have pi over 4. And when I look at the unit circle, sine of any angle is the y value, cosine of an angle is the x value, and tangent is y over x. So my sine value is the y root 2 over 2. So that matches what we just found. All right, let's do another one. Cosine of 150. Again, there are two ways to do it. I'm going to do it with a reference triangle first, but then I'll bring back the unit circle. Remember, reference triangles, you don't have to memorize this year, but if you do, trigonometry, next year's class for pre-calculus will become much easier. All right, so there's two ways to do this. I can do it with a reference triangle or the unit circle. Now, cosine of 150, 150 degrees, that's in my second quadrant. In the second quadrant, my x values are negative, my y values are positive. So I can figure out this reference angle here. And so this reference angle will be its distance from 180. So my reference angle is going to be 180 minus 150. 180 minus 150 is 30 degrees. So my reference angle down here is 30 degrees. That means when I draw this, this is a 30, 60, 90 triangle. So on a 30, 60, 90, this vertical, the short side is 1/2, and the horizontal is root 3 over 2. But we are to the left. We're in the second quadrant, which means it is negative root 3 over 2. So cosine is my adjacent over my hypotenuse. And so my hypotenuse is always 1. So my adjacent would be negative root 3 over 2. So cosine of 150 is negative square root of 3 over 2 based upon that reference angle of 30 degrees. And so I could go look at my unit circle to see it a different way. If I go to my unit circle, here I am. And if I find 150 degrees, here's 150 degrees. So there's my ordered pair, and cosine is my x value. So what's the x value? Negative square root of 3 over 2. So I could have directly referenced the unit circle as well. Okay, but in the future and next year, you will have to either memorize this whole circle or just your two triangles and just be able to find the reference angle. All right, let's try another problem. Okay, sine of negative 750. So if I'm doing sine of negative 750, my problem right now, I couldn't directly use the unit circle because it's not between 0 and 360. Unit circle is all about between 0 and 360. So I need to find its coterminal angle. So to find its coterminal, I'm going to add on 360. And if I add on 360, I am left with negative 290. Hold on. No, 390. Negative 390. And so if I add another 360, I'm left with negative 30. So I'm still not to the unit circle, so I add another 360. And I'm left with 330 degrees. So sine of negative 750 degrees will be the same as sine of 330 degrees. So this time I'll use the unit circle first, and then I'll show you how to find it with your reference angles. So now that I have a value on the unit circle, I'm going to go look at my unit circle. So here's my unit circle. So now I want to find 330 degrees. So 330 degrees is right here. And we're trying to find sine. So sine is a y value. So my answer will be negative 1/2. So we had sine of 330, which is negative 1/2. Now let's just confirm it with a reference triangle. So 330 degrees is just short of a full circle. So we want to find its reference. And between 0, 360, and 180, it is very clearly closest to 360. So its reference will be 360 minus 330, or 30 degrees. So this reference angle, the angle it makes with the x-axis, is 30 degrees. And so that means I have a 30, 60, 90 triangle. So in a 30, 60, 90, the long side on the x-axis, the side adjacent to 30 is always root 3 over 2. The side opposite 30 is always 1/2. But now let's figure out positive and negative. I'm to the right, so the x-axis is positive, but I'm down, so this y value should be negative. All right. So I'm going to get negative 1/2 because sine is opposite 30, so negative 1/2.